parametric equations of a curve are x is equal to te to the power 2t and y is equal to t square plus t plus 3. Part A is we have to show that dy by dx is equal to e minus 2t. So we are given the curve in the form of x and y, but x and y we are not given directly in the form of each other. Instead, we are given them the form of t. Now we are to find dy by dx, which is the gradient. We'll have to use a different method than simply finding out the derivative of each. So what the method we use is, since we don't have their direct relations, we find their indirect relations by using dy by dt and dt by dx. So when we represent them like this, the dt's cancel each other out and ultimately give us dy by dx. This we can do because we are given x in the form of t and y in the form of t. So let's find out dx by dt first. So in the equation of x, we have two terms, t and e to the power 2t. And these two terms are multiplied to each other. So when we have two terms multiplied to each other and we have to differentiate it, what we do is we write the first term as is, so t. Then we write we differentiate the second term. So d by dt of e to the power 2t. And we add the second term, e to the power 2t, into the differentiation of the first term. Okay, so this is the formula we use when we are differentiating two terms multiplied to each other. So t is t as is. The differentiation of e to the power 2t is 2e to the power 2t. We don't touch the exponent while we differentiate or integrate. It's just that in integration, the exponent is divided, and in differentiation, we multiply the exponent. So over here, since it's differentiation, we're just going to multiply the 2 to e to the power 2t. And the second part is simply e to the power 2t, since the differentiation of t with respect to dt is always 1. So 1 into e to the power 2t is e to the power 2t. Now this is a correct answer, but we can simplify it to make it easier for us. So if we take e to the power 2t constant, so we write 2t plus 1. Now we have it in an easier form to understand. Next we have dy by dt. This is easier to do since this is a straightforward quadratic equation. So first what we do is we write down the first term, which is t square. So we take out the power, so 2, we write t, and we subtract 1 from the power. So 2 minus 1 is 1, so 2t to the power 1. Second term is minus t. So what we do, is it minus t or plus t? Let me check. It is plus t. Okay, so it's plus t. So what we do is, since it's plus t, the differentiation of t with respect to dt is 1. So we add plus 1. And then we are left with plus 3. Since 3 does not contain any term of t, that's differentiation is 0. So ultimately our dy by dt is equal to 2t plus 1. Now notice how 2t plus 1 is present in both places. This will make it easier for us to calculate dy by dx when we are multiplying, because then we can simply cross things out. So our dy by dx is equal to dy by dt into dt by dx. So dy by dt is 2t plus 1, and our dt by dx is just the reciprocal of dx by dt. So we take 1 on top, and underneath we write e to the power 2t into 2t plus 1. So then, since we have 2t plus 1 in both the numerator and denominator, we simply cross them out. So what we're left with is 1 to the power e to the power 2t, which is written as e to the power minus 2t. Now if we look at our question, yep, that is what we're supposed to be getting, e to the power minus 2t. Hence we have proved that dy upon dx is e to the power minus 2t. Okay, question 5 part B. Hence show that normal to the curve where t is equal to minus 1 passes through the point 0 and 3 minus 1 upon e to the power 4. So from our previous question, we get to know that dy by dx, which is the gradient, is equal to e to the power minus 2t. So let's just write that down. Dy by by dx is equal to e to the power minus 2t. So at a point when t is equal to minus 1, the gradient, which is dy by dx, becomes e to the power 2, because minus 2 into minus 1 is 2. So this is the gradient of the curve at that point. But what we have to show is that the normal to the curve at that point passes through another line. So let us take the equation of the normal to the curve as y is equal to mx plus c, which is the standard line equation. So first let's find the gradient of the normal. So since the gradient of the curve is e to the power 2, the gradient of the normal, which is m, is the negative reciprocal of the gradient to the curve, which becomes minus e to the power minus 2. So now we know that the normal is y is equal to e to the power minus 2 minus x plus c. Now we also know from the previous question that x is equal to t into e to the power 2t and y is equal to t squared plus t plus 3. So let's write that down here also. X is equal to t into e to the power 2t and y is equal to t squared plus t plus 3. So now we know this also. So when t is equal to minus 1, let's find out the value of x and the value of y. To substitute into this equation right here, so we can find the value of c and create the straight line equation. So when t is equal to minus 1, x is equal to minus e to the power minus 2 and y is equal to minus 1 whole square is 1 plus minus 1, so minus 1 plus 3, which is 3. So x is equal to minus e to the power minus 2 and y is equal to 3. So if we substitute these values of x and y into the straight line equation that we have to find the value of t, what we get is 3 is equal to minus e minus 2 into minus e minus 2 plus c. So this minus minus become plus over here, since 2 minus make a plus. So 3 is equal to e to the power minus 4 plus c. Since when we multiply something with the same base but different powers, what we're doing is we just add the powers. So minus 2 is minus 4. So hence we get to know that c is equal to 3 minus e to the power minus 4. So this is our y-intercept. This is the y-intercept. When x is 0, c is the value of the y-intercept. So what we have to show is we have to show that it passes through the point 0 and 3 minus 1 upon e to the power 4. So basically we just write it down as y is equal to minus e minus 2x plus 3 minus e to the power minus 4 when x is equal to 0, y is equal to 0 plus 3 minus e minus 4. Since x is equal to 0, this entire first term becomes 0 since anything multiplied to 0 is 0. So y is equal to 3 minus 1 upon e to the power 4. Hence, it passes through the point 0 and 3 minus 1 upon e to the power 4. Hence proved.